Hello there. In continuation of your kinematics of the particles, so we are here to solve one more problem. So to understand the kinematics of the particles, so one should have to follow the sequence of the video lectures so that we can get a better knowledge and we are going to be prepared by ourselves to solve the unknown problems also very easily. So what is the main difficulty in the unknown problems? The main difficulty is that what are the parameters we need to be calculated? What is the availability data? That kind of the practice we generally are doing over here by using the skeleton diagrams, right? So let me start for today's session and how we are going to be solving this problem. A blocks A, B are mass 10 kg and 30 kg. So here the mass of the block A is going to be the 10 kg here is given. Similarly, the mass of the B is equal to the 30 kg. The data has provided respectively. Are placed in a 30 degrees inclined plane. There we can see the diagram also. The theta is equal to 30 degrees we got it. And here is the mu A is equal to 0.25. In this case, we are going to be calling the coefficient of friction between the block A and the plane. So that I am going to be say the mu A is equal to 0.25. And similarly, the mu B also available. That's the coefficient of friction between the B as well as the plane. So that's going to be mu B is equal to 0.15. So then, what is the force between them as they slide it down? It means that he has provided the motion of the object is going to be moving in the downward direction. And we need to find out the force between A as well as the B, this force. So, between the forces we need to be calculated. And secondly, the acceleration of the blocks we need to be calculated here. That is the AA as well as the AB we have to calculate it. So, I am going to be writing here the force between the blocks I need to be calculate, acceleration of A and acceleration of the B we need to be calculated. So it is the data is available and we are applying the kinetics of the particles. It means that the kinetics of the particles and the kinematics of particles, both the equations we are using to solve the problem here. Once we identify, I am going to be draw the free body diagram. The free body diagram, first I am going to be taking the block A. So there we can see the block A is going to be existed in this direction. Right? Suppose assume this is the A. So can you see, I have removed this inclined plane which is making 30 degrees to the horizontal plane. Once I remove, I need to show with the reaction force that I am going to say NA. To avoid the confusions, because we do have the two blocks, that's why I given the notations here is the NA. And similarly, what will happen? The self weight of the object is moving in the downward direction. So from this part, the self weight is going to be acting WA. I am going to be say, right? WA is going to be the self weight of the block A. And similarly, the motion of the object is going to be in this direction. That is the motion. Right? The motion is moving in the downward direction. So then what will happen? When I am going to be separated from block A and the block B, so then I am going to be shown one of the react force is going to be acting in this direction. Suppose I am assuming block B is going to be exerting a force on the block A. That is only the assumption. So then what else other forces we will have? There is the frictional force also going to be acting on this member, and the motion is towards this side means the frictional force is going to be acting towards this side. That is the FF already we do have using this notation. And similarly, the inertia force also going to be, we need to be considered in our equations to solve the further. So then we need to be simplify these equations. So then what are the equations we do have here? That's going to be WA is going to be there. So that's going to be making an angle of 30 degrees to the vertical plane here. So when I am going to be taking over here, right? So that forces we are going to be considering. One is going to be acting normally to is, one is acting, this cell plate is going to be acting parallel to the inclined plane. One is going to be acting normally to this plane. Can you see here? So I am going to be resolving this one into the two categories. So if I am going to be resolving this weight into the two components, so what I am going to be getting here? So that's going to be, one is going to be your sine, one is going to be your cos component of the weight we are going to be getting. Alright? So that components are going to be, so this is going to be your opposite side, WA sin theta we are getting, and this component we are going to be getting WA cos theta we will get. Alright, the forces, because these forces are going to be normally to the inclined plane and this is going to be parallelly to the your inclined plane. So I need to find out the NA value by taking the sigma f of y is equal to 0. Here this is going to be perpendicular to inclined plane. Perpendicular to the inclined plane. So what are the forces we do have? That's going to be NA is acting upward direction. This is acting in the downward direction. WA cos theta. As you know, WA I am going to be taking here is going to be MAG cos 30 degrees. Then finally 10 into 9.81 cos 30 means root 3 by 2 we are going to be taking. On this basis, NA is equal to, then what is the value of the NA? That's NA is equal to 84.95 newtons. I got it. Can you see? By using the planes, the forces which are perpendicular to the plane we have taken. So now once we are going to be calculating, we can calculate the frictional force. So how could you calculate the frictional force over here? So as we know, the frictional force is equal to, see here, the frictional force is equal to mu into NA. That is going to be the coefficient of friction as well as the normal reaction. Once if I am going to be substituting in this equation, what I am going to be getting here, mu A is equal to 0.25 and here is the 84.95. Then if I am going to be simplifying this equation, what is the value of the frictional force? The value of the frictional force, finally I got it, 21.24 newtons. Right? This is the frictional force belongs to the block A as well as to the F plane. So that I am going to be taking FFA is equal to 21.24 newtons. Right? So we have calculated the FF and this NA value we have calculated. And then we need to be calculate the Fy. So then how could you calculate the Fi? So in this case, Fi is equal to your inertia force is equal to mass of the block A and acceleration of the block A. So Fi is equal to 10 into A I am going to be taking. So this is going to be, I am considering the equation 1. Right? So then what I am going to be, we need to be calculate the acceleration of this block A as well as the B. So Fi is equal to 10A we got it. So that I am writing here, Fia is equal to 10 into A. Right? That equation I can use in the later stage. So now what I am going to do, I want to be write the equation. What is that equations we do have? What is that equation? That's going to be, I am writing which are going to be sigma x is equal to 0. In this case, which are parallel to plane, inclined plane. So what are the forces we do have? That's going to be W sin theta, frictional force, inertia force. So this is acting towards this side, these two are acting opposite this direction as well as the P also available. So these two forces, P plus WA sin theta minus of F frictional force minus of inertia force is equal to 0. Because these two forces are acting opposite direction, these two are acting in this direction. If I am going to be substituting in this equation, I will get unknown equation, that is going to be the P is the unknown parameter WA is equal to mass into 9.81. Suppose if in that case I am going to be getting, if I am substituting 10 and sin 30. So the finally here is going to be m into z, right? WA is equal to m into z, and sin 30 is equal to 1 by 2. So the finally I am writing that equation. It's around 49.05 minus of the frictional force is equal to 21.24 minus 10 into A is equal to 0. And further simplification, we will get it the P minus 10A plus. So when we are substituting 49.05 from this equation, I am going to be getting 27.81 is equal to 0. Can you see this equation we generated? Alright, once we are getting this equation, so then I am going to try to find for the B block also. So once we completed for A, now I am going to be taking for the B. This is the block B, right? And this is going to be your normal reactions in B. Sulfate is going to be acting in the downward direction, that is going to be WB. So right, and this is going to be the motion of your object towards this side. And your frictional force is going to be in the opposite direction. Similarly, your inertia force also in the opposite direction. So then, what are the forces we need to be considered over here? So similarly, I am going to be resolving the forces. One is going to be which is going to be normally to this part. So sorry, the sulfate always acting vertically downward direction. This is the WB. So I am going to be resolving the forces in this direction. So one force is going to be in this direction, another force is going to be in this direction. So it's going to be like this. So this is the force. And here it is going to be making an angle of 30 degrees. So if I am going to be resolving WB sin theta, and this is going to be WB cos theta. Okay, and from this one we need to be find out the equation over like this. This is the equations we need to be generate from this equation, from this figure. So I am going to be taking which is going to be perpendicular to plane. Perpendicular plane means here sigma f of y is equal to 0. Suppose in this case what will happen? That's going to be NP is equal to WB cos 30 degrees. We will get it. WB is equal to here. What is the mass of this one? 30 kgs. 30 into 9.81 cos 30 is equal to what is the value? Root 3 by 2. If I am going to be simplifying, NB is equal to what is the value of the NB? That's going to be 254. The 254.87 meters. Can you see? NB we got it. Then once we got it, I am going to be substituting in the frictional equation. What is the frictional equations we do have here? The frictional force is equal to B is equal to mu B into NB. So can you see here the mu B is equal to already 0.15. 0.15 into 254.87. Then finally f of B, that is going to be your frictional force, is equal to the value is going to be 38.23 newtons per meter. So we got the frictional force. FB is equal to 38.23 newtons. NP is equal to 254.87 newtons. So now we need to be taking another equation which is parallel to the plane. So which are going to be parallel to inclined plane. So what are the forces we do have? And in this case what will happen? This force is trying to move in this direction. In previously the block B is going to be applying the force on A is in this direction. The block A is going to be applying the force on this direction. We will get it. So the same equations we are going to be writing. That's going to be these three forces are in the right side and this force is in the left side. So that I am going to be taking the P. So that's going to be, so simplifying that equation, WB sin theta is equal to P plus frictional force plus inertia force. Further simplification of this one, P, FB is equal to 38.23 newtons. FIB is equal to, we do have MA into, that's going to be your B into AB minus of WB sin 30 degrees equal to 0. So I am going to be simplifying this equation because the P plus 30 AB plus, so this is going to be 38.23 minus WB is equal to 30 into 9.81 into 1 by 2 is equal to 0. So further simplification of this equation is equal to P plus 30 AB. So here the simplification I am getting here minus 108.92 is equal to 0. See, from this equation we got the two equations. I am considering this is the third equation. Now I am going to be equating these two and we are trying to solve the problem. Here is the equation 2 as well as the equation 3 we got it. But in this form we are unable to solve this equation. So what we have to assume here, the P is going to be the common, but it has a different accelerations in this equation and then we need to be calculated. In the two unknowns equations we are going to be getting. So then what we are going to be trying to do, I am going to be assuming if A acceleration of the block A is equal to acceleration of the block B, that's going to be your common acceleration. That means what I want to assume here, these two have a single acceleration. Then I am going to be substituting in this equation. So that this same condition I am going to be writing here, if AB is equal to A. So then this simple I am going to be simplifying this equation. So what I am going to do, I am going to be doing the subtraction or the additions, minus plus. So then what happened, plus P minus P is going to be cancelled. Here is going to be the minus 40A and here is the plus, and these equations we are going to be getting around 3, 18, 16 plus 17 dot 18, 16 and then 3. That means 176.73 we are going to be getting. So further simplification, A is equal to, when I am going to be taking to the right side minus we are going to be cancelled here, 136.73 by 40. So what is the value of the A? So from these equations we got it, that's going to be 3.421 meter per second square. So that means AB is equal to 3.421 meter per second square. Once if you assume this condition, then only we are able to solve it. So in this case what will happen, we got the I. So that means acceleration of these components. So now what I am going to do, I am going to be find out the force P. That means I am going to be substituting any one of this equation. So I am substituting in this equation, that's going to be, so this is equation 2 already I told. So that means substitute A in equation 2, P minus 10 into 3.421 plus 27.81. So then that is equal to 0. If I am going to be simplifying, the P is equal to, I am going to be getting 6.29 newtons. Can you see here? I am going to be getting, here is the negative. It means that I have taken the equation 1. It means that this force I assume in this direction, right? So this is going to be the reverse direction, the force is going to become. This way we are going to be calculating the magnitude of the force as well as the acceleration of these blocks A as well as the B. I hope you are able to understand. If you feel still any difficulties, please put in your comment section so that I will try to answer those questions. Thank you.